In this video, we're going to take a look at how to use the GNU C++ compiler to compile single source file programs and multiple source file programs in C++. The steps that I'm about to show you will also work for C programs as well, because the GNU compiler is actually a collection of compilers for which there's a C++ compiler, a C compiler, a Java compiler, and actually other compilers as well. So the key command that we're going to be using during this video is the G++ command, which is the command for compiling a C++ program. There's also the GCC command, which would be used to compile a C program. So other than that, the steps for compiling C++ and C programs are identical. Now, I happen to be working on a Macintosh running Mac OS X and using a terminal window to show you the steps that we're about to perform. However, everything I show you here should also work on any Linux or Unix system, because the GNU compiler collection is typically installed by default with each of these operating systems. Now, if you want to use the GCC or G++ compilers on Windows, there's actually a couple of projects that you can take a look at for using the GNU compilers on Windows. There's the MinGW project, and there's also the Cygwin project as well. So MinGW is at mingw.org, and Cygwin is at cygwin.com. In the case of MinGW, this is really just the compiler, and it gives you some tools that allow you to have a command line look and feel like what I'm about to show you running in my terminal window on Mac OS X here. In the case of Cygwin, it gives you basically a simulated Linux environment that runs inside of a window on your Windows computer. So you'll certainly want to take a look at those two projects if you'd like to work with the GNU C++ compiler on Windows. Now, for the purpose of this demonstration, we're going to work directly in our terminal window. And I'm assuming that you've already downloaded the examples for your book and extracted those examples to your system. In my case, I placed the folder, which is called Examples, in my Macintosh account's Documents folder. You may choose to place the examples in a different location, so you may have to slightly change the commands that I'm about to show you in order to match the location where you extracted the files. Now, again, because they're in my Documents folder, I'm going to change directories to that Documents folder using the cd, or change directory command. And so I'll type cd documents, and when I press enter, you can see that my command prompt now says I'm in the Documents folder. And the folder that contains the examples is called Examples, so I'm now going to cd to the Examples folder. And when I press enter and type ls to list the directory contents, you can see the set of folders that make up the examples in C++ How to Program. Now, the next thing we're going to do is actually change into the directory for one of the chapters. And in particular, we're going to start by taking a look at Chapter 2. So let's change to the Chapter 2 directory and type ls to show you the contents. And you can see here we have a number of files that end with the .cpp, which stands for C++ extension. In addition, if you were going to be doing this with a C program, the extension would be .c instead of .cpp. Now, to demonstrate the first program from Chapter 2, I'm going to be compiling the figure2_1.cpp file. And the way that you're going to do that is by typing G++ and then the name of the file. So 02_01.cpp. And when I press enter, it's going to go ahead and compile the file. And now if I type ls, you'll notice that there's this file a.out listed in the directory listing, and that is the compiled program, and specifically its executable version. So when you compile a program in C++, there's a process called the preprocessor that executes first. Then there's the compilation process, which creates the so-called object code representation of the source code. And then that object code is linked together by the linker with the various libraries that we use to create the final executable. Now, if you want to execute the a.out file, you can type // and then a.out. And when you press enter, it will show you the results of the program, which in this case is simply welcome to C++. Now, as you can see in this particular directory, we happen to have a whole bunch of different programs. If we compile each of those programs, what we're going to find is that each one is going to keep overwriting that a.out file, which is not really what you want in most cases. You'll notice as you move into later chapters in the book that we often put each individual program into its own separate subfolder for a given chapter, and that's because once you get into more substantial programs, you'll typically have multiple source code files per program, and we wanted to organize them better. Now, if you happen to have multiple programs in one directory, a better way to execute the compilation command is to use the -o output option, which allows you to name the executable. So let's say, for example, that we wanted to name that program that we just compiled figure02_01 for its executable. So this -o space and the name of the executable is going to tell the compiler where to place the executable. And then again, we can specify the name of the file that we wish to compile. And when we press enter in this case, you can see that we now have this fig02_01 file, and just like before, I can execute that by saying fig02_01 preceded by the // and when I press enter, once again we see welcome to C++. And everything that I just showed you will also work for C programs. The key difference is that instead of saying G++ here at the beginning of the command, we would say GCC for the GNU C compiler. Now, so far we've looked at compiling and running single source file programs. But as you get into larger examples and larger applications that you're building, you're going to have multiple source file programs. So what I'm going to do now is go back one level in my directory structure by typing cd space and .. That's going to take me back to the examples folder, and you can see that here as well. And let me just type ls again, and for this purpose we're now going to jump to chapter 9, which is where we introduce the concept of classes. So let's cd ch09, and when I type ls, you can see that we have a number of different examples that we're presenting here. Let's go ahead and just pick one. I'll do the one figure 13_15 here, which means that the code for this example is in figures 9.13 through 9.15. So let's cd to that folder. And when I press enter and type ls, actually that's not the best example, so let me change from that one, and we'll go to the previous example in there. So cd fig09_10_12. Sorry about that. So now if we take a look at the list of files in that folder, you'll see that there's a time.cpp file, a time.h file, and a figure9_12.cpp file. So there's 3 source code files that make up this program. Now, in order to build the application, build the program so you can execute it, all of the source code needs to be compiled and linked together to create the final executable application. So one way that you can do that, if you have just one program within a given folder, is you could type G++ and then *.cpp, and what this will do is it will grab all of the .cpp source code files, compile them all, link them all together, and produce the final executable. And in this case, because I'm not using the -o command, it's going to produce the file a.out. And let me just go ahead and hit enter. And when I type ls, you can see once again the a.out file here. Now, of course, we could have said G++ -o, excuse me, and then the name that we wanted to give the application. So fig09_ let's try that again. 12, there we go. And then we could say *.cpp, and when we hit enter in this case, it's going to produce the executable by the name that we specified. Now, notice in both cases that I said nothing whatsoever about the .h file, which is a so-called header file. Remember when I first talked about the compilation process that I mentioned the first thing that happens is something called the preprocessor executes. The preprocessor's job is to include header files into the source files that request them. So if you were to go look at the source code in time.cpp and figure 9_12.cpp, you'll see that both of those files contain what's known as a #include directive, the hash symbol followed by the word include, and then they are specifying that the time header file should be included into time.cpp and into figure 912.cpp as well. So the preprocessor is actually automatically going to pull that header file into these two source files, so we don't have to worry about including that as part of the compilation directive. And now we can go ahead and execute our program. So again, we'll do /figure 9_12, and when we do that, we can see the output of this particular program, which is demonstrating a concept called default arguments to a constructor, showing you the values that are being passed to a constructor to initialize a time object. So again, all of these commands that I was just showing you with respect to compilation can be performed for C++ programs using G++, or for C programs using GCC. Other than that one difference, the commands, and of course in C programs, you'll have .c files instead of .cpp files. So other than those two differences, the commands are basically identical for both C++ and for C programs.